one of the present commonly prominent physicists, Michio Kaku, has discussed his evaluation with respect to this issue. Kaku, perceived for his remarkable contributions to the fields of physics, has recently avowed that the James Webb Space Telescope has found 6 immense cosmic systems that scientists thought couldn't exist. These assessments have the potential to open up new perspectives in our logical comprehension of the universe. It is, therefore, fascinating and worth watching out for these changes. Kaku is an uncommon figure in the scientific field, a physicist of American and Japanese heritage, considered a master in both traditional exploratory physics and quantum mechanics. Unlike some more moderate and skeptical scientists, Kaku doesn't belong to that group and has been open to the surprising aftereffects of the James Webb Space Telescope mission. We are satisfied that this distinguished scientist has chosen to end his silence and transparently share what can no longer be denied. The excitement and almost engaged tone of the famous physicist are clear in his comments on the discoveries made by the James Webb Space Telescope, imparting that this has been the highlight that has excited his interest. Join us to explore the ramifications of Michio Kaku's revelation of these 6 enormous cosmic systems. Kaku is a scientist who has always been able to think about new theories throughout his life. He knows that Einstein's theories of relativity and Newton's laws are insufficient to capture the full complexity of the universe. Kaku understands that the discoveries of the new telescope can potentially improve the scientific field, although many of his colleagues have not been able to embrace this view. It is causing concern and sleeplessness among defenders and adversaries of quantum mechanics. Anyway, this just incites laughter from Kaku. The JWST has uncovered the revelation of 6 enormous worlds tracing back to the earliest legends of the universe. Each of these cosmic systems contains more stars than our own, despite having formed just a short time after the Big Bang. The group of cosmologists who made the discovery has named these exceptional systems universe breakers, as their existence would change our whole understanding of the universe. Something doesn't fit here any longer. The theory of the Big Bang tells us that the universe was a wreck after the initial event. The first solid objects required numerous centuries to form, and it took innumerable extra years for the objects to reach a productive density and produce light. The development of complex structures like systems was supposed to happen much later. Some of the newly found systems outperformed the Milky Way in size, and their colossal radiance shows that they were probably forming many new stars each year, while our system forms stars only intermittently. It remains unclear exactly when the first worlds formed. Researchers have not been able to determine this until recently. The only thing that is clear is that initially, there may have been just single stars or gatherings of stars that eventually came together to form progressively larger structures, leading to the development of dwarf galaxies, which experienced consolidations and gradually advanced. According to past hypotheses, extremely coordinated and gigantic systems could not have existed at that time, raising the question of whether the universe is much older than previously accepted or whether complex toroidal designs grew significantly earlier. This situation is challenging for moderate science, which still struggles with this model. Furthermore, some areas of physics have strongly rejected this discovery, addressing possible mistakes in the age calculations. Kaku was aware of this, and had this to say: there are various occurrences of old and misleading hypotheses that obstinately continue due to the prominence of certain scientists. Many of these speculations were eventually disproven when vital research uncovered their false notions. Consequently, the key work in any science, especially in physics, rests with the experimentalists who maintain the research's authentic truth. As a matter of fact, on Earth, we have practically no knowledge of the genuine beginnings of the universe. The Big Bang hypothesis was laid out in 1927 based on observations of the universe's development. This information led to the conclusion that the universe began from a singular point and has been growing ever since. At the time, it was challenging for people and researchers to imagine a universe with a start and an end. The possibility of a universe that had always existed and was limitless in time was beyond human imagination. Indeed, even today, researchers still face hardships understanding it. However, it is critical to re-examine these possible outcomes. These novel perceptions do not fit at all with what researchers have relied on for quite a while in the Big Bang hypothesis. Yet science has shown time and again that reassessment and receptiveness to groundbreaking ideas are significant parts of the scientific process, just as much as the affirmation of specific hypotheses and observations. When Einstein was a child, it was believed that the stars and planets were firmly fixed in the universe, and these particular arrangements consumed a defined space. However, we now realize that everything in the universe is moving. Planets orbit stars, stars move within their galaxies at numerous kilometers per second, and whole galaxies move rapidly through the universe, the fate of which we can't yet even predict. Today, researchers are challenged to accept uncomfortable insights, and it is recognized that hypotheses are not simply guesses nor essential facts until they are fully tested or confirmed by precise observations. The idea of the Big Bang arose out of the acknowledgement that galaxies are moving away from one another, and this distance is relative to the distance from Earth. This observation, known as Hubble's law, proposed that the universe was expanding. For some time, parts like astronomical microwave background radiation and the red shift of light from distant galaxies and other cosmological structures appeared to support this hypothesis. However, it is essential to remember that in the past, people who believed that the Earth was flat and that the Sun circled around us also had this kind of proof for their suspicions, until events or technological advancements provided a clearer and more precise picture. Right now, we are seeing a comparable circumstance. Researchers expected the new JWST to affirm the assumptions connected with the Big Bang, yet rather they have come across 6 systems that appeared incomprehensible. This reminds us that science is continually progressing and that researchers must be open to new discoveries and rethink existing hypotheses in light of available evidence. Researchers utilize red as a tool to determine specific amounts in the investigation of the universe. Red shift, also known as the Doppler effect, refers to the adjustment of the color of light as the light source and the observer move relative to one another. To understand this, you can imagine stopping and watching a vehicle coming towards you. As the vehicle moves towards you, you hear the engine getting louder. However, once the vehicle passes you or moves away from you, the engine sound changes. This is because the sound changes as the vehicle moves. The same is true for light. When a light source, such as a distant star, moves towards us, the light we see shifts towards blue tones. Conversely, when the light source moves away from us, the light shifts towards redder shades. This phenomenon is called red shift. Physicists have converted red shift values into velocities and distances for measuring amounts in the investigation of the universe. However, it is critical to note that small errors in these measurements could have huge implications. The measurement methods previously used are now under review, and the results that specialists will arrive at concerning the latest discoveries related to our universe are interesting. It is pivotal to consider whether these outcomes are genuinely based on shift errors, or whether some specialists are simply denying the facts. This is a question that requires intensive assessment and careful review of the data and methods used in the research. As scientific inquiry progresses, the discoveries made by instruments like the James Webb Space Telescope frequently challenge our assumptions about the universe. The new revelation of 6 huge cosmic systems tracing all the way back to the early sagas of the universe is one such example. These cosmic systems, which resist regular hypotheses of universe formation, raise significant questions about the timeline and components associated with the development of large structures. The James Webb Space Telescope, a replacement for the Hubble Space Telescope, is equipped with cutting-edge technologies that enable it to peer deeper into space and see with outstanding clarity. Its ability to detect light from the distant reaches of the universe provides astronomers with a window into the past, allowing them to study galaxies that formed billions of years ago. The discovery of these old and gigantic worlds challenges existing models, which predict that such large structures ought to have formed much later in the universe's history. The ramifications of these revelations extend beyond astronomy and into the realm of fundamental physics, compelling scientists to reevaluate established theories about the early universe, including the theory of the universe's origin, which posits that the universe began from a single point and has been expanding ever since. While observational evidence, such as the vast microwave background radiation and the red shift of distant galaxies, initially supported this hypothesis, the discovery of galaxies that appear too developed for their age complicates this narrative. Michio Kaku, a prominent physicist known for his work in theoretical physics and popular science, has commented on these advancements. Kaku, known for his ability to connect complex scientific ideas with public explanations, recognizes the pivotal potential of the JWST discoveries. Unlike some of his more skeptical colleagues, Kaku embraces the idea that momentous observations should provoke modifications in scientific thinking. He has emphasized the importance of experimental evidence in shaping our understanding of the universe, highlighting that theories must continuously evolve to accommodate new data. The debate ignited by these discoveries reflects the dynamic nature of scientific inquiry. On one hand, there are advocates who argue that the discovery of early massive galaxies suggests a longer timeline for cosmic development than previously thought. This perspective challenges the traditional view that galaxies evolve gradually over millions of years through mergers and steady growth of smaller objects. On the other hand, skeptics warn against hastily discarding established models based on limited observational data. They advocate for a cautious approach, suggesting that peculiarities in data interpretation or measurement errors could explain the astonishing findings. Red shift, a phenomenon observed in the light emitted by distant galaxies, plays a critical role in these significant investigations. As galaxies move away from Earth, the light they emit appears shifted towards the red end of the spectrum. This observation, known as red shift, is used to calculate the speed and distance of galaxies.